Balancing chemical equations is one of those concepts in chemistry that tend to give people some confusion. But I think we will find that if we handle this in a methodical way and have some appreciation for balancing, it's not so bad. Okay, so first of all, what is a chemical equation? Well, this is a chemical equation in front of us, and what it's telling us is that if we have some aluminum, it will react with oxygen and form this product, which is aluminum oxide. Okay, so what does it mean to balance? Why is this not a balanced equation? What's wrong with that? Well, everything on this side of the arrow is a reactant, and everything over here on the right side of the arrow is called a product. Now, we have to have the same type and the same number of atoms on both sides, right? If we look at this, if we look at the left side, the aluminum over here, there's only one of them, but on the product side, there's two of them. Now, aluminum just can't appear out of thin air. It's not by some miracle that it shows up. We have to figure out how this is actually reacting. The same goes for the oxygen. On the reactant side, I have two oxygens over here, but on the product side, there's three of them. Okay, so we have to figure out how to balance. In other words, we need this number and this number to be the same, and we need the oxygen numbers to also be the same. We cannot change the subscript. In other words, these numbers down here, these are the subscripts, and they cannot be changed. We can't do anything to them because these compounds go together in what's known as a fixed proportion. Aluminum oxide is always going to be AlO3, Al2O3, because of the charges. We need the compound to have a net charge of 0, and aluminum has an overall charge of +3, and oxygen has a charge of -2. So when we put these things together, we need them to have an overall charge of 0. They need to cancel out. So that means that I need to have 2 aluminums for every 3 oxygens, so that the charge for the positive is +6 and the charge for the negative is -6, and overall it's a charge of 0. Okay, so we can't do anything with the subscripts, but we can use what's known as coefficients. So if we look at this equation, we're going to look at this equation, we are going to see if we put a 2. If we put a 2 in front of the aluminum on the reactant side, then we will have 2 aluminums on one side, this side, and 2 aluminums on this side, right? This is now 2. Okay, that's good. Now let's look at oxygen. Oxygen has 2 on this side and 3 on this side. Now, you can look at this and think, well, if I put a 1.5 over here, right? If I put a 1.5 times 2, if I double 1.5, then I have 3. Then this becomes 3. And now it looks good, except it's weird to have 1.5 molecules of something, right? That's just weird. We want these numbers to be whole numbers, okay? So what do we do about this? Well, one thing we can do is multiply everything here. All our coefficients we can multiply by 2. If we multiply by 2, then we'll have whole numbers. Okay, so what does that mean? Let me rewrite this. Let me rewrite the equation. I have Al plus O2, and I have Al2O3. Here's my arrow, right? Now, if I take all of my coefficients, right, and I times it by 2, right, then let's see what happens. Now, this aluminum oxide, the product, aluminum oxide, we know if there's no number implicitly, that means that there's a 1 over here. Let me change that color. We know that there is a 1 over here, okay? So let's multiply all the coefficients by 2 and see what happens. Well, 2 times 2, that gives us 4, and 1.5 times 2 gives us 3, and 1 times 2 gives us 2. Now this should be balanced, but let's check. Let's check what we have on both sides and see if this equation is balanced. If we have an equal amount of atoms on this side as we do on the product side. Okay, so aluminum on both sides. On this side, I have 4 aluminums, and on this side, I have 2 times 2 aluminums, 4 on the product side. Okay, so aluminum looks good. Aluminum checks out. Aluminum looks good. Let's check our oxygen. On the reactant side, I have 3 times 2. I have 6 aluminums over here. And on the product side, I have 2 times 3. That gives me 6 aluminums over here. So this is a balanced equation.